Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Please confirm to me. All right. Good morning, guys. All right, sir. Now, so we are understanding the second approach of creating threads. Then first approach of creating threads we already completed. One time if we check the one time, that means first approach of creating threads, if you understand it, what exactly the threads design here we are having. First of all, now tell me what is threads and in how many ways we are able to create threads. If you have to this, thread is a flow of execution to perform a particular task. Then after that, in how many ways we are able to create threads, if you have to this, as per the predefined library provided by Java, there are two ways to prepare threads. What are the two ways to prepare threads now? First one is by extending thread class, and second one is what there, by implementing runnable interface. Threads design. All right, first approach, extending thread class. If you want to go for this first approach, now steps are very clear. Declare an user-defined class, extend user-defined class from java.lang.thread class, overwrite run method in user-defined class with the application logic which you want to execute by creating thread. Inside this run method, we have to provide some application logic that we want to execute by creating a new thread. Which logic we want to execute by creating a new thread, that logic we have to keep inside what their run method. That's the point I'm telling to you. In main class, in main method, create an object for the user defined class and access start method. In main class, in main method, create an object for the user defined class and access start method. Where start method is only the method in Java to create a new thread. No other method is having functionality of creating new threads. Only start method is able to create new flow of execution, new thread inside the Java, and access run method internally. Start, see, in the case of this threading, we are not going to call run method explicitly, not at all required to access run method explicitly. But who is going to access run method explicitly internally? Start method will call run method. So the start method functionality is what? Two responsibilities for start method. One is creating a thread, send the thread to the run method. Now the thread will execute run method. That's it. We are not going to call run method explicitly. Start method will call run method internally. public void start, public void start. Next one is what there, class welcome thread extends the thread, public void run method for int I is equal to 0, I less than 10, I plus plus, system.out.println of welcome thread colon I. This is user defined thread run method. Public class test, public static void main string array args, welcome thread object we created, welcome thread dot start method. When we call this welcome thread dot start method, thread class start method will be executed. Inside the thread class start method, new thread will be created. That new thread will be assigned to what their run method. Now this run method is going to be executed. Got it or not? Meanwhile, main thread will come back to the main method. Main thread will continue the further remaining part of the execution. So at one side, main thread is executing remaining part of the main method. At the other side, welcome thread is running, is executing run method. So two threads are executing parallelly. By that, we are able to get mixed output. What output here we are getting there? No, mixed output. This is exactly the process here what we are having. Right, so Java C test.java, Java space test. Now we are getting that mixed output like what there? Main thread, use welcome thread, main thread, welcome thread. Like this here we are getting some outputs here. But remember this, in multi-threading, max we are going to predict what type of output only we are going to get. The type of output may be mixed output or sequential output. That's it. There is no guarantee to get the same time same output on every time execution of the program. One time to another time, that output may be varied. Output may not be same from one time execution to another time execution. Max we are going to understand what type of output here we are going to get. Is it a mixed output or sequential output? That one only here we are going to understand. Right, sir? Now let's understand this point clearly. After this, now this is the total diagram here we can understand. What is this diagrammatic representation there? Observe carefully. Right, so now class thread implements runnable. This is thread predefined class. That what I have taken. This is like what their welcome thread. Okay, now here JVM. When we provide Java space test, JVM will create a thread. This is main thread. That JVM will create a main thread. That main thread will execute main method. Inside the main method, first it will create object for the welcome thread. It will start wt.start method. Automatically main thread will go to thread class start method, where logic to create new thread will be executed. New thread will be created. The new thread will execute the remaining part of the start method. Then meanwhile main thread will come back to what their main method, continuing the remaining part of the execution. Now inside this start method, new thread will check it. If r double equals to null, yes it is null, it will call current class run method. But current class run method is overridden by welcome thread class run method. So flow of execution will come to what there? Welcome thread class run method. In welcome thread class run method, so that for loop is going to be executed. One time that for loop is executed, insert the welcome thread. Next turn is coming to what their main thread. Main thread is executing one iteration over the for loop in the remaining part of the main method. So the same thing is going to be continued until the completion of both the threads. Altogether, what output we are able to get there? At one time main thread, next time welcome thread. One time main thread, next time is what there? Welcome thread. Like this, we are able to get what there? Mixed output here we are able to get. Answer my point here. So this is the way of executing what there? More than one thread at a time in a single Java application. That output here we understood. After this, I've taken one more program. Inside this program, how many thread classes I created here? 3 thread classes I created explicitly. But one thread is what their main thread. Main thread plus 3 thread classes are executed at a time. So overall 4 threads are executed at a time. Because of this 4 threads execution at a time, the total output we are getting in a totally mixed output. The completely mixed output here we are getting there. If you understand the nature of this output now, easily we can identify high thread, main thread, hollow thread, welcome thread. Next one, allow thread. Allow thread. Next one is what there? Main thread, high thread, main thread. Allow thread, welcome thread, hollow thread. Like this. See, time to time, we are unable to predict the sequence. For example, if you are trying to follow this type of sequence, no. High thread, main thread, hollow thread, welcome thread. Like this, if we think about the same in the next output, no. But immediately it was changed. Next, what we are getting there? Hollow. That means hollow thread we got. But initially, what we got there in the first sequence, no. High we are getting. Now here we are getting what there? Hollow. So we are unable to predict it. We are unable to predict the outputs in the case of like what there? Multi-threading. Yes, sir. Answer my point here now. See, I think already I given one example in my BTech, last year BTech and multi-thread. Last year or maybe some year that exam is there, but no faculty is available to teach Java for us. By the time we got a faculty, we got a trainer from Anantapur JNTU. Anantapur JNTU, we got a professor for teaching Java. He came to the class. He started his explanation. Up to few concepts, theoretical points, he explained very clear, but we understood that. But what happened there? So he's taking his first of all on white marker board he write the program and he wrote the program. He explained the total process and he provided some output. What output there? Welcome thread, hello thread, welcome thread. Like this, he fixed that output. Then after that, when he come back to the system, when he execute the program inside the system, when he tried for it, there what happened there? There automatically didn't get the same type of output in the system. He got some different output. Again, he's trying to execute the program the second time. Second time, some other output he got. Next time, some other output. 10 times he executed. 10 times different outputs he got. Then what happened there? All the people are laughing in the audience. Audience said all the people are laughing. Then he feels shy for it. Just he said to us, 10 minutes I want to take break. No, he came outside, but he didn't come back. No. Yeah, then for us in my college, multi-threading was not completed. The only first application or second application might be completed. Understand it? Again. This is a funny experience what I got there in my BTech college. That the same thing was happened. So by the time software boom is very good, very good. Everybody, if you know basics of Java, you are getting jobs there by the time. But nobody is available for us to teach Java by the time. Understand it? Again. But anyway, it's okay. That's a different experience. What I'm telling you know. But the point is what he missed out actually. He doesn't aware about the point. In multi-threading, outputs are not static. Outputs are varied from one time execution to the another time execution. Why this variation is coming? Why this variation is coming? Why? Because internally thread scheduler is available. I explained previously process scheduler, process multi-process mechanism. Similarly, internally thread scheduler is available. That thread scheduler will assign some timestamps for each and every thread. For one thread on moment 2 units of time it may assign. For some other thread on moment it will assign 4 units of time. For some other thread it may assign like what there again 1 unit of time here. But we don't know how much timestamp that the thread scheduler is going to assign. That's a random value, but we don't know that. On the basis of the timestamp value only, the thread's execution is going to be happen. Because of that reason only, we are going to get what there variation over the outputs from one time execution to the another time execution. Is it all of you following or not? So you also, by seeing this variation in the outputs from one time execution to another time execution, don't get irritation over Java. Then you may be think about it. In my friend system, one type of output we are getting, and moreover, in my system, this output I'm getting there. I'm giving that output in the document, but don't type the program as it is. Don't run the program. Don't compare your output with my output. In general, you are doing the same point. Before this class, now whatever the outputs I'm getting there, just you are checking your output and my output. If both are same, then you are feeling very happy. Okay, my program is right. But don't do that in the case of multi-threading. Why? Because at present in my laptop, this moment I executed the program, though I got that output. Next minute, if I execute the same program, no guarantee to get the same type of output. But how can you compare your output with my output? Your output is different, my output is different, maybe. But by seeing that, don't think about it. Here my output is wrong. So what I have, don't think too much about it. If you think too much about it, you may get irritation over Java. Understand it, Ken? So this is multi-threading. In multi-threading, outputs are variable from one time execution to the another time execution. From system to the system, outputs are going to be varied. One simple point we can recognize it. No, in the last class, what I have done, when I execute the program in IntelliJ IDEA, I got one type of output, but my required output are not generated. Then immediately I copied the same program in where there in Edit Plus or maybe Sublime Text. There I compiled and executed the program. I got my required output. But of course, finally, I seen that mixed output in both the cases now. Got or not? So there itself we can identify how these outputs are generated now. Okay, leave it. So this is the about first approach of creating the threads now. Just leave this one. Now the second one is what we are understanding the second point now. To create threads, we already have the first approach, that is extending thread class. Then what is the requirement to go for another approach, that is implementing runnable interface? Simple. It's a somewhat common sense related point. If we want to create threads in first approach, we have to extend the java.lang.thread class to the user defined class. Public class my class extends thread. In the above case, if we want to extend some other class to the user defined class, then it is not possible. Why? Because it represents what? Multiple inheritance. The same point I have said to you, public class my class extends thread comma frame. Frame in the sense GUI part I said to you know previously. If you want to extend frame class and if you want to extend thread class, my class should be the frame class and as well as what the thread class. If it is a case now, there we are going to get what there like compilation error. Whenever we are putting this comma here after that one super class, if we put comma, there we are getting what there compilation error. There is invalid case now. It is not possible. To overcome this problem, we have to use another approach of creating thread, that is implementing runnable interface. If we are implementing runnable interface, then there is a chance for one class to extend. Am I right or not? There is a chance of extending one class to our class. That advantage here we are getting it now. Public class my class extends a frame, implements what their runnable interface. Now this is exactly the situation where we are going to use what their second approach of creating threads now. Got it or not? Simple point. Don't ask me, sir, which one is better and which one is not better now. Both are better only, depending on situation only we have to use. If you want to extend some other class there in our class, no. If you want to extend some other class along with thread class, no, go for this implementing runnable interface. Or if you are not having any other class to extend here, just simply override, that means extend what their thread class. That depends on our situation. But as per my consultation, what happened there, in my cases, maximum wherever I want to take the thread now, I'll give my first priority for extending thread only. It's a by default, common sense. I don't have any intention to use only this first approach now. Automatically, as I practiced very well about the first approach, as I'm seeing somewhat number of cases more inside the second approach, no, I feel first approach is somewhat automatically is compatible with me. That's why I'm using that first approach. No. Not only me, maximum developers automatically they are going to use what the first approach only. There is a default. What I'm telling, their habit. It's a habit for every developer. Got my point or not? So in general, in every case now, first concept is getting more priority, second concept is getting less priority. Everybody will remember first topic perfectly, second topic automatically they're having a little bit less. Am I right or not? In that mode, in that calculations, you can understand. But there is no advantage with first approach. There is no drawback with what their second approach. But still, if you want to talk about the advantages, no, second approach is giving a little bit advantage when compared with the first approach. But still people are using what approach as the first one? First approach only. Understand? Just it is a habituation for Java developers to use first approach. Right, sir. Leave this one. After completion of this, in the second approach, what exactly the work is available? And try to recognize this. Second approach, declare an user-defined class, implement what? Java.lang.runnable interface. Provide implementation to the run method in the user-defined class. In a main class, in a main method, create a new thread and execute the run method. In the main class, in the main method, create a new thread and execute the run method. Okay, this step we are going to understand more. Cases here we are having there. To create a new thread and to execute run method, we will use the following cases. First of all, I prepared this thread class. What is about the thread class here we prepared now? Class my thread implements runnable, where run method here we have taken. Case 1. My thread empty is equal to new method. Just we can understand all the cases are available inside the test class. Okay, now inside this public static void main. Public static void main string array argsum. Inside this main class and main method only, all these cases are available. Not in any other location here, no. All these cases are available where? Inside the main class and main method. What is this case 1? Directly we are creating my thread empty is equal to new my thread empty dot start method that we created. Got it or not? Empty dot start method here we called. Observe carefully. Whenever we are calling empty dot start method, first compiler will search for start method in my thread class. Do you have any start method inside the my thread class? No. Then compiler will search for this start method inside the interface. What is that interface actually? Runnable. Inside the runnable interface, we have only one method. Am I right or not? Right, now let me check it. What method is available inside this runnable interface now? Java p java.lang.runnable. Right, sir? How many methods are available inside this runnable interface? No, only one method. What is this method actually? Run method. So inside the runnable interface, we have only run method. That run method anyway is available inside the implementation class also. Now tell me, where is the chance of having start method? Do you have any start method in mythread class? Is the start method is anyway any relation with the mythread and runnable interface? No, because of that reason here we are getting what there compilation error. What's the reason why we are getting compilation error? Start method was not defined in the thread class. Leave this one. Was not defined in the thread class in the sense this one my thread class. Yeah, that will be good thing. Why? Because java.lang thread is a class where start method is available. Don't misunderstand that is thread class no. My thread class. Thread class in the sense user defined thread class no. Leave it. Next one is after that case 2 I provided. What is that case 2 no? From this first case, what is the realization here no? From the first case, the realization is what there. Anyway, start method is not available. So we are unable to access start method. But even though if we access start method, finally which method is executing? Run method only. Even if we call start method, finally which method is executing? Run method only. So instead of in this indirect approach no, why don't we call directly run method of the mythread class no? Answer my point here. Why don't we call this run method of the mythread class no? We are getting that kind of thought. That's why I maintain this for the second case. Mythread empty is equal to new mythread empty dot what method here? Run method. Mythread empty is equal to new mythread empty dot what there? Run method. Now here what happened there? If we call this empty dot run method, status is what there? No compilation error. But what happened there? Who is executing this case to actually main thread? This is what we where we provided this one inside the main method. Who is executing this main method? Main thread. When main thread is coming to empty.run method, same main thread will go to what? My thread class, where it will execute what? Run method as like a normal Java method without creating any new thread. After executing that run method, main thread will come to what there? Main method and execute the remaining part of the main method. It's almost the same as sequential output or not? Executing run method, after that only executing what their remaining part of the main method. This is almost all equal to what their sequential output. Am I right or not? Right, sir. That's the problem. So here the point is what? Only main thread will execute the my thread class provided run method and main method, not by creating new threads. Only main thread will execute the my thread class run method as like the normal Java method, not by creating new threads. That's the point here we are getting. So here there is no multi-threading concept. No multi-threading. It's clearly what there is single threading. No new thread is created inside this approach. Right, sir. Now this is what we are getting clearly. Understand it now. Case 3. What is this case 3 actually? My thread empty is equal to new my thread. Okay. From this case to what we got the realization of? We got the realization like what there? Without using start method, we are unable to create the threads. Without using start method, we are unable to create the threads. If we want to create a thread, definitely we require what method? No, start method. This point already I confirmed it. I given clarity on this point previously. Where I given clarity on this point there? 1 minute, sir. When I have given the steps for the first approach, no, there I given clarity, much clarity I given for it. All right, sir. Now please read this statement here. What I have given? Where start method is only the method in Java to create a new thread, that is flow of execution and access run method with the new thread. Got or not? No other method is having that capability. Only start method inside the thread class is having capability to create a new thread and to access the run method internally. Leave it, sir. Yeah, now coming to this one. From the case 2, what is the realization here? Without using start method of the thread class, we are unable to create a new thread. But as per the requirement, we have to create a new thread. So definitely we have to use what the start method. Then immediately, what happened here? My thread empty is equal to new my thread. Thread t is equal to new thread. After this, here we provided what there? T dot start method. Got it or not? Now here we understood T dot start method here we called. So T is what their thread class reference now. Got it or not? So, but here what happened there? No compilation error and no output. Why we are getting no compilation error, no output here in this case? No. Reason is new thread is created, but it executes thread class provided run method. But it executes thread class provided run method, not user defined thread class run method. But our requirement is what? We have to create a thread, new thread. That thread must execute what run method? User defined thread class run method. That is welcome thread class run method. But what it is executing? Thread class run method it is executing. Inside the thread class run method, just open and close is available. No implementation is available. Yes, sir, got or not? Inside this thread class run method, just empty implementation is available. So directly that user created thread, new thread will execute that thread class run method. No output is going to be generated. No output will be generated in this particular case. Got it or not? But here our requirement is what? We have to execute welcome thread class run method. But we executed thread class run method. Right. From in this case, we have to tell to the thread class. We have to tell to the thread class start method. What the thread class start method? No, create a new thread. Okay, well and good. But don't execute thread class run method. Send the thread to what there? My thread class run method. We have to tell this information to thread class and its start method. Create a thread, well and good, no problem. But don't execute thread class run method. Why? Because nothing is there inside the thread class run method. Nothing is available inside the thread class run method. Just it is open and closed. Now we are not going to execute anything. But you have to execute what class run method? Welcome thread class run method. So to give that information, in the case number 4, what I have done there? In the case number 4, what we have done there? Just we created my thread class object. Then after that, we passed that user defined thread reference as parameter to thread class run method. When we pass user defined thread class might be user thread reference variable as a parameter to thread class constructor, internally inside the start method, it will check parameter is available to the thread class constructor or not. If it is available, then access empty.run method. If it is not available, simply access run method. Run method in the sense thread class run method. Empty.run method in the sense what there? My thread class run method. Then directly flow of execution will go to what there? My thread class run method. So to bypass our newly created thread to the my thread class, we need to pass my thread reference variable as parameter to thread class run method. Now here we are getting the status now. What status here we are getting now? Tell me. No compilation error and a thread created successfully and executed run method of the user defined thread class. Is that clear? So these are the points we understood in the last term. Few days of time, then 2 days of classes here we understood. I explained that clearly. Now I want to show the same points as it is in a system inside our content here. Now try to understand it clearly. Of course, we can use this IntelliJ IDEA, but in IntelliJ IDEA only the thing is what there. It is executing the threads in a fast manner within a single times of that entire thread is executing. Get my point? And that's why it seems like sequential outputs, but don't think about it. They're like what they're mixed output only. But if I down to the edit plus or maybe sublime text now, there we are getting that mixed output here now. Okay, now let me show that examples in what they're mixed output here. Now let me check it. What is going to be happening here? All right, sir. 1 minute. Let me try with IntelliJ IDEA. Then after that, I'll move on to like what there other content here. Where it is like what? Yeah, 10 a.m. core Java. It's okay, fine. Okay, no, I want to create it separately. I think something is available. Right now, full stack Java 10 a.m. Yeah, 22 applications are already completed. It's okay. App 23 Java IntelliJ IDEA. It's everything is okay. Click on create button. This window. Okay. That's all. Is it okay? The dark background, high context, visible? No? It's okay? Right. So all cases here I'm going to show with you. Now try to understand it. First of all, I have to take a class welcome thread. Now what is the second approach of creating the thread? Now welcome thread must implement one interface. What is that interface? Now right, implements runnable interface. Runnable interface, how many methods are available here in runnable interface? No, how many methods are available? Only one method. What is that method? No, run method. You must implement that method. Implement method run. Click on OK. Right, now we are implementing that. Now inside this, just I want to take what there for int I is equal to 0, I less than 10, I plus plus. Now inside this sysnot outer println of, now just here I want to provide something like what there welcome thread. Just I want to display like what there welcome thread. Values also here I want to display plus I. This is completed. Next one is what after this main class here I'm going to take. Inside this main class here what we are going to do there. Now I need to create like what there welcome thread object here I'm going to create. Welcome thread is equal to case one I'm going to show. Now try to understand it clearly. Welcome thread is equal to new welcome thread. New welcome thread object here we created. In case number one, what we provided, sir? Now tell me. Welcome thread dot what method here we call there start method. There we are getting error. Now it is in red color. It is in red color in the sense what's the meaning of it? No, what's the meaning of it? If it is in red color here, definitely we are getting an error now. So now it is not good. Now here what I am telling to you. So just I commented case one is completed. Case one is completed. Leave it. Next one is what is this case to know? From this we realized that what we realized here. Anyway, even though if we call start method, it is calling internally run method. So why don't we call run method directly? That's the question here. That's why we are going to call what there run method directly. So now here we have to provide what there welcome thread. Welcome thread is equal to new welcome thread. Welcome thread is equal to new welcome thread. Next one is what? After this, after completion of this welcome thread, no, I need to call welcome thread dot run method. At the same time, now here I want to take one more for loop there. And I is equal to 0, I less than 10, I plus plus. Now inside this sysnot outer println of, here we have to provide something else like what there main thread. Main thread plus I variable here we provided. It's okay. Then for int I is equal to 0, I less than 10, I plus plus sysnot outer println of main thread colon I that we are getting now. Now all of you observe carefully. Now in this case, what is the analysis part now? When main thread created an object for this welcome thread, it's okay, object will be created. When main thread calls this run method, directly it will go to welcome thread class and execute run method, where it provides output is what there welcome thread 10 times. No, after that only main thread will come back to the main method and continue the remaining part of the execution. There in the remaining part of the execution, what output we are getting now? Main thread 10 times now. Execute 1000 number of times. Output will be very same. What is that output now? Welcome thread 10 times, main thread 10 times. Welcome thread 10 times, main thread 10 times. In this way only we are able to get output even if we execute multiple times. Why? Because here there is no chance of getting mixed output. Why no chances of getting mixed output here in this case? No. Why? Because second thread is not created. Welcome thread is not created. The flow of execution is not created. Second flow of execution. That's why there is no chance of getting what there mixed output. Always we are able to get what there sequential output only. Why? Because only main thread is executing welcome thread class run method, remaining part of the main method. Now let me execute this. Right, sir. Now see this one. We are getting some output here. So welcome thread. Next one is what there main thread. Execute any number of times here, but still we are able to get like what output here? The same output. Any number of times here we can execute, even if we execute, but we are able to get the same type of output. Execute any number of times. There we are able to get like what there welcome thread 10 times and main thread 10 times. So the same output here we are able to get. Clear to all of you? Right, sir. Now this is exactly the meaning of this particular content here. Just leave this one. This is completed. So from this, what is the realization here? No. What is the realization here? Without calling thread class start method, no new thread will be created. Only main thread is created. It is only executing the total program. But if you want to execute multi-threaded application, we have to create a thread explicitly. To create a thread, we have to use what there? Thread class start method. Understand it now? The next one is what? Then after that, what we have to use there? Case number 3, welcome thread. Welcome thread is equal to new welcome thread. Object will be created. Then after creating this object, then what next one here? Welcome thread. Welcome thread is equal to new welcome thread. Thread object also will be created. Why we are creating thread class object now? We understood that we need to access what there? Thread class start method. Because of that reason, we created what there? Thread class object. Thread is equal to new thread object here we created. Insert this. Then after that, here what we are doing there? Thread dot what method here now? We have to call start method here we call. And moreover, this one for loop is required. Now tell me, what is that internal point here about this particular one? Now tell me, when main thread is executing this one, okay. When main thread is creating object for thread class, okay. When main thread calls thread.start method, in a thread class start method, new thread will be created. But the new thread is executing what class run method? Thread class run method, not what there? My thread class run method. Is it got it or not? Why? Because no relationship is existed between welcome thread class and a thread class. Two separate objects we created, but they are not interconnected. The two objects are not interconnected. The two objects are not at all having any relationship. So how this thread class is going to send the thread to the welcome thread class run method here if no interconnection is available between these two classes? No. Is it? Are you getting it or not? So because of that reason here, what I am telling you, thread dot start method here, when we call there, new thread will be created. That new thread will send, that new thread will execute what class run method here? Thread class run method instead of what there? Welcome thread class run method. Got it or not? Next one after that. Now here, what output here we are able to get? No, in this case we are going to get output from only main thread. No output will be generated from what there? Welcome thread. We are going to get output from only main thread, not from what there? Welcome thread. Now let me execute this program. What output here we are getting there? Only one thread output, that is what their main thread output. Execute any number of times here. Here we are able to get output from what there? Only main thread. Main thread 10 times here we are executed. We are getting output like what there? 10 times that main thread now. Okay, right, sir. So this is another one. Yeah, from this point, what is the realization here? What we understood there? What is lacking this particular point here? What we have to understand? Now we have to talk with the thread class. What we have to talk there? When I call the start method, we can create a new thread, but don't send that new thread to the thread class run method. Why? Because nothing is there inside the thread class run method. You have to send that thread to what there? Welcome thread class run method. There only I have written my application logic. Then to give that information to the thread class, we have to pass my thread class or welcome thread class reference variable as parameter to thread class constructor. In that way, then only thread class will send that the new thread to the where my thread, that means welcome thread class run method. Now let us check this clearly. Welcome thread is equal to new welcome thread object here we created thread is equal to new thread of, then what next one here? Welcome thread. Now here we are getting it. Then after this, here we need to call what there? Thread dot what method here we are calling? Start method. Clear? So now we are going to get like what there? Mixed output. We have to get it. Yeah, it seems like what there sequential, no? I said to you. Now we can understand it, mixed output. Luckily we got that mixed output now. But if I execute one more time, it may be like what there sequential kind of output. But the nature is what there? Mixed output only. Okay, now we are getting what there? Mixed output. Okay, now I think this program I have not given there in the document. And if we cross this phase, of multi-threading, up to now, if you understand multi-threading clearly, if we cross this phase of multi-threading, remaining concepts are simple. Only the difficult part is what there? Understanding these examples. Understanding up to this part is the difficult part. The remaining part of the multi-threading is very simple. Why? Because everything is under our control, but up to this is not in our control. That's why people are getting confusion. If I go for next concepts, every concepts I can control. Programmatically I can control the threads execution. Understand it here? Okay. Right. So now let me copy this one also. Output here I want to check it. Again. Right. So I want to show that internal flow of execution of this particular approach. The second approach, internal flow, I have not discussed with you. Now I want to discuss with you or try to understand it clearly. First of all, let me open it. First of all, what we have to do there, right, sir. So first of all, I want to write class public class thread class predefined implementation here I'm going to provide. Implements runnable. Inside this runnable r is equal to null. Public thread of zero argument constructor. Public thread of runnable r. Now inside this dot r is equal to r. Now what next one here? After this, some other constructors are also available. We don't require that. In a thread class library, we will discuss about all the constructors separately, but we don't require at present. I require only two constructors. The two constructors here I have discussed with you. One is zero argument constructor, another one is what there parameterized constructor. The parameter is what the runnable reference. Public void run method. So no implementation is available, just it is open and closed. Public void start method is available. Then inside the start method, what I am going to write now? Logic to create new thread. See, there also be how that new thread is going to be created. I have an idea, but how much you are going to understand it is a difficult case. That's why I'm giving a single line like what there logic to create new thread. Okay, just I'm giving information, outline information. I'll try to understand it now. The start method will call internally a native method start zero. That native method start zero is having implementation at a hardware level code. That hardware level code is creating new thread and is submitting the new thread to the our start method. Now start method is taking that new thread. What is this, sir? What you are talking in the next 2 minutes of time? Okay, just forget it. That's why I've written the point here. What is the point I'm telling there? Logic to create new thread. One question now, final question. Now try to answer for it. Who's creating this flow of executions actually? Process is there. Who is creating that process actually? Very first question I've asked with difference between process, processor, and processor. Who is creating that process? No, processor. Processor is a hardware component or software component? Hardware component. So if you want to get any flow of execution, you need to have interaction with the hardware or not. So means that some work we have to do at hardware level or not. Some work we have to something we have to execute at hardware level or not. So by the execution of that hardware code only, flow of executions are going to be generated. Am I right or not? So simply we are calling that when we call thread class start method, automatically new flow of execution is created in the sense how it is created without having hardware interaction. If you want to interact with hardware, first we have to interact with the operating system. Through operating system, we have to interact with what their hardware. Understand my point? That means at least we need to execute something at our operating system level or not. Process will come from hardware. At least from this process, we need to get a separate piece or not. The thread we are going to get at least from operating system or not. So at operating system level, we have to execute some code if you want to get the thread. So, but method must be declared in Java, but its implementation must be available either at hardware level or at the operating system level. Yes, sir, got it or not? So if any Java method has the declaration in Java implemented in some other language, that method is called as what? Native method. So now here internally native method is available. What is that native method? Something like what there? A start zero method. Some number, some method, start zero method. By calling the start zero method, automatically it will interact with the operating system and it will create a thread. That thread will be taken into the Java program. Now that thread is available in our thread class start method. This much of internal concept is available. Then only we are getting it now. Got it or not? What I'm telling you now. Right, sir. Anyway, whether you understood it or not, that doesn't matter. In the very first line, what we are having there, logic to create new thread. Then after that, what happened there? When new thread is created, the new thread will execute the remaining part of the start method. What is that remaining part of the start method here? If r double equals to null, if r double equals to null, there we can call what method here? Run method. Especially we can use this keyword, this dot run method. Internal it will be like this, or simply run method. Else part. Else part. What is this else part actually? That means r is having some reference value. Then we can call r dot run method. This is the total internal flow of execution inside what class can know? Thread class. Clear? All of you clear about this implementation part? Only see inside the thread class so many constructors, so many variables and so many methods are available. But only required information only here I have written, right? Next one is what? After this, after completion of this, observe carefully. What about our program here? Class welcome thread implements what their runnable interface. Now public void run method. Inside this run method, what we have taken there? For int I is equal to 0, I less than 10, I plus plus. Sysnot outed println of welcome thread. Main class here we are providing. Now class test. Public static void main string array aux. Now here I want to explain the cases now. Try to understand the cases here. Case 1. What is that case 1? Now tell me. Welcome thread w2 is equal to new welcome thread. W2 dot start method. When we call the start method, flow of execution will come to welcome thread where it will search for what there? Start method. Compiler will search for start method. Do you have any start method here? No start method. That's why we are getting compilation error. Leave this, not required now. Next one is w2 dot run method. If you call this, now here also I am going to provide what there? For int I is equal to 0, I less than 10, I plus plus. Now inside this system.out.println of main thread. Like this, here we are getting it. Now inside this, what we are doing now? Welcome thread w2 is equal to new welcome thread that we provided w2.run method. Only main thread will go to the welcome thread and execute the total run method. 10 times we are getting output welcome thread. After that only the same main thread will come back to what their main method and execute the remaining part of the main method. There we are getting output is what their main thread. Sequential output only we are able to get in this case now. Okay, leave this one. Next one is thread t is equal to new thread t dot start method. When we call t dot start method, what happened? New thread will be created. Okay, understand it now. When main thread calls this t dot start method, main thread will go to what method? Start method of the thread class, where it will create a new thread. Now new thread will check it if r double equals to null or not. R value is what they now tell me? Null or not? When it is null, it will call what method? This dot run. This dot run in the sense what class run method? Thread class run method. Inside the thread class run method, do you have any implementation? No implementation. Nothing is going to be executed. Finish. Then main thread. Meanwhile, main thread will come back to the main method and execute the remaining part of the execution. In the remaining part of the execution, what we are getting there? Main thread output here we are getting. What output here we are getting there? Main thread output here we are getting continuously. Only main thread output we are getting, no output from what there? Welcome thread here. Why? Because JVM is not executing. That means new thread is not executing welcome thread class run method. Leave this one. But if you want to execute welcome thread class run method, we need to pass welcome thread reference variable as parameter to like a thread class constructor. This here we have to pass as parameter to thread class constructor. Understand it clearly? Now this one I want to show in a flow of execution. Try to understand this content clearly. All of you observe carefully. This is command prompt. This is command prompt. Now get Java C space test.java compiled successfully. Java space test. D colon slash Java 10 Java space test. Automatically here what happened there? JVM will be activated. This is JVM software. JVM will be activated. Then JVM will load test class bytecode to the memory. After that, JVM will search for the main method. When it is identified, JVM will execute main method. JVM will execute what method here? Main method. When JVM is executing main method, JVM will come inside this one. It will execute what method here? No, welcome thread. Welcome thread object is created. Okay, now let me create this welcome thread object also. No, understand it? Here we are getting welcome thread object. This is welcome thread object. A reference variable for this welcome thread is what there? WT. The WT reference variable we provided to this welcome thread. Now the reference value of this particular reference variable is what there? AB56 for example. This is a reference value. Reference value is what there? Welcome. AB56 is the welcome thread reference value. Okay, that is created. Next one is when JVM come to, that means main thread is coming to the thread T is equal to new thread. Now it will execute what there? New thread class constructor. New thread class constructor. When a new thread class constructor is available, come here, come this location. Yeah, your cell phone. Yeah, you come. Yeah, your smile is very good. Come here, no problem. Arey yaar, starting point of the class, I'm observing clearly to you. You are disturbing all the entire environment. Come, otherwise then it is not good thing. Come here. At the 2 minutes of time, you are talking in front of your person there. 2 minutes of time, you are talking next person. Next 2 minutes of time, next person you are talking. Now come here. No. You will corrupt all the remaining members here. You are the most dangerous person inside the class. Two worst person today now. Then, if possible, give your parents' number. I'll talk with your parents. I'll talk with your parents. No, this person, your son, is corrupting the total class. He had two girlfriends. He's rotating in outside of the class only, not coming to the class regularly. Every day I'm seeing your son there in outside of the Maitrivanam building only. In IMAX there 2 times I have seen. In Charminar location 3 times I have seen. In Charminar and was there his son name and some other girl name is there. No. Then try to check it. Like this I'll give that information to your parents. After the class give your parents number. So you're totally most dangerous person, right? Fine. Now you can understand Java. Observe carefully. Right. Listen now. Important point here itself I am giving clarity. No, understand it. No. So new thread of like what there? Welcome thread we pass it here. Put more concentration. What reference here we provided, sir? WT. What is the WT value? AB56. AB56 is what the reference value. Immediately here AB56 is a reference value that we provided here. Okay, then immediately flow of execution will come to, from this constructor, flow of execution will come to thread class constructor. What constructor it will be executed there? Thread class constructor. That is what their runnable reference. Now tell me, this AB56 is a welcome thread class reference in the sense indirectly it is runnable reference or not? Am I right or not? It implements what the runnable. So it means that automatically the WTs are the runnable interface class. So its reference is nothing but runnable reference. Automatically that 56 AB56 value will come to like what there R variable. Now inside this what we are doing there, AB56 value is available to this. Now that value is assigned to the same this dot R or not? AB56 value is coming to this dot R. This dot R in the sense like what there, null is available previously. In place of null, what value here we are able to get now? AB56 value is available. AB56 value is available. Got it or not? What I'm telling you. Right, sir. Whenever we are getting this AB56 value here, okay, that is completed. Now object is created. Thread class object is created. Not required to maintain the thread class object here. Just object is created now. Then immediately main thread. That means this main thread. But after execution of this main thread here, after completing execution of this particular part here, after assigning that WT reference variable to R, flow of execution is coming back to what there next line. Flow of execution is coming back to what line? Next line. Next line of creating thread. That means already or else maybe. Directly we can understand it. No. Flow of execution is coming to what there? To the same line. That means thread class object is created here. Constructor is only be executed. Object is created. Flow of execution is coming to the same line. Then flow of execution is coming to the same line. Then immediately T dot start method. T dot start method. When we call this T dot start method, again what happened there? Main thread, the same main thread this time will come to start method. Here start method is available or not? Yes, here start method is available. Directly it will come to what method? Start method. Now it is executing what method here? Start method. Now it is executing what method here? Start method. Observe carefully, inside the start method what happened there? Logic to create a new thread. Logic to create what thread? No, new thread. Already said to you know, by executing some native methods internally, it generates some flow of execution. That flow of execution is giving to start method. So finally new thread is created. When a new thread is created, immediately what happened? New thread handovers the remaining part execution of the start method. New thread takes the responsibility of executing remaining part here. Meanwhile, what main thread is doing now? At the same time, when it is a handover, the remaining part execution to the new thread, then main thread will come back to the main method to execute, to continue the remaining part of the execution. Got it or not? Parallelly, main thread is running its content here. Understand it? It executes this one-time iteration over the content here. Here we can expect the output is like what there? Welcome thread that we are getting there. Sorry, main thread. Main thread output here we are getting one time. Parallelly, user thread is created or not? New thread is created. Flow of execution is created. That flow of execution is checking R double equals to null. No, R is not equals to null. What is R value? AB56. R value is not null. Flow of execution will come to what there? Else part. In else part, what it is executing there? Inside the else part, what it is executing there? Directly, it is executing R dot run. Now tell me guys, what is this R dot run actually? R dot run in the sense like what there? AB56 dot run. R dot run is what there? AB56 dot run. AB56 value is what there? AB56 is a value for which variable? WT variable. Am I right or not? Alright, so now WT dot what method can know? Run method. WT dot run method in the sense we are calling That thread, user defined thread, newly created thread is calling what method? Welcome thread to class, run method. Immediately from here, flow of execution is coming to like what there? Directly welcome thread to class, run method. Flow of execution will come to what there? Welcome thread to class, run method. Of course, while executing this part, this entire part, one more time maybe main thread may be executed parallel to this. We can understand it now. When it handovers to the newly created thread, main thread will come back to what there through the main method. It will continue its remaining part continuously. Parallelly, at the same time, new thread will be executing this run method. It will come to what there welcome thread class run method. Then it will execute. There it will execute what there welcome thread class run method. One time it will execute. When it executes one time, then what we are getting there here automatically here we are getting like what there welcome thread object here we are getting. Welcome thread output we are getting. Next turn. Now time caching is time stamping is going to be start. Scheduling is going to be start. Few minutes of time, few units of time, main thread, few units of time like what there, use that. Both are going to be executed here now. Now if it is a case now, next turn is coming to watch. Next turn is coming to what there, main thread. Now main thread is executing next point here. When it executes this next point, here we are getting output like what there, welcome thread. Sorry, main thread. Main thread will be executed. Next turn is given to like what there, user thread. Going to be executed. Alright, so now it is going to be executed. When it is executed like this case, then we are getting output like what there, welcome thread. Now here we can understand like what there, welcome thread. The same process is going to be continued with the time, that means context switching, the same thing is going to be continued until the last iteration of the loops. Alright, so now here we are able to get the continuation output like what there and so on. Now here also we'll have what happened there. The last iteration of like what there, this particular user defined thread. Both are executed here. Now here we are getting like what output no? Alright, now this is like what there. Welcome thread. Like this, we are going to get the 10 outputs. 10 is from main thread and second another 10 is from what there? Welcome thread, but both are going to be executed continuously. When main thread is executed, main thread is going to be in data state now. When user thread is completed its execution, then user thread will come into what there? Data state. Finally, both the threads are in data state. Finish, our program is going to be executed totally. This is the total internal flow of execution. How threads are created in the second approach. That's it. So one question I'm asking, sir, if you are not attending this class, just if you are dependent on only document, whatever the document I'm preparing now, how can you understand this by seeing only this document? Here only we are getting some rough lines only. What you are going to understand? No? No. That's why then class is mandatory. Then if you understand class, if you know the class, then only we can understand the flow of execution clearly. Okay, but if you have knowledge on Java, we can understand it now. At least by seeing the arrow marks there, easily we can understand if you know. But on movement, if you observe this, just rough lines we are getting. But lot of information is available here. How thread is created internally, given the total content. So anyway, then from your side, what I am expecting there, try to practice one time. Try to practice this entire flow of execution one time. If it is possible, try to teach this topic to somebody else. Sure, then try to explain this concept to somebody else. Not to search for any other persons now. In your class itself, your friends are available. Okay, now you can teach your girlfriend. They're at Charnar when we meet. Right, sir. Let's move to the punch. So this is completed, sir. Now overall, what we understood there, threads design topic is completed. Totally, what topic is completed here? Threads design topic is completed. Next one is what? Thread life cycle. The next topic is what there? Thread life cycle. What exactly the meaning of thread? What is this thread? Thread life cycle. What is the meaning of life cycle? First of all, what is the meaning of life cycle, sir? Or what is the meaning of life cycle? What you are understanding about life cycle? Say for example, everybody they are having nowadays maybe biographies, right? Yes, sir. Am I right or not? Previously might be then now. 15 to 20 years back now. So some others are going to write the biography for the freedom fighters. Mahatma Gandhi biography, or maybe Jawaharlal Nehru biography, but we can see this kind of biographies now. But nowadays, if the person is a famous now, then there is a movie already planned there on the basis of this Virat Kohli. Already Muralidharan movie was there. Sachin Tendulkar movie was existed. MS Dhoni movie. MS Dhoni movie is ultimate. Yes, sir. Am I right or not? What is the overall story of MS Dhoni? If he lost one, search for another, right? No? No. That movie was very good. But then Dhoni is somewhat intelligent here when compared with all other persons. No? He knows about the public pulse very well. As a politician also, he will be very good. Definitely, he will success in that area also. Maybe you may think about it. Indian cricket board, in the sense, there's a lot of politics. Even in that politics also, he was gained and he was the person who survived in that politics. Understand it now? Especially so many members are having so many politics there. But still he survived in Indian cricket, in the sense, is a good thing. As a number one place in Indian cricket. Understand it, Ken? Okay, but he led the team very well. That is at one side. At the same time, his approaches of handling the issues, that is another one. Yeah, definitely. We need to take inspiration and we have to learn so many things from him. Really. Why? Because then how he handled the difficult situations in a cool manner, but everybody knows about it. Everybody is very, very interested about cricket. You already aware about it. You have watched him. He was already, you are watched that his captains and everything. But where we have to learn it, if any difficult situation is coming, you should not give up. We have to stay there. We have to handle it, and you have to move that game into the very close. At the same time, people are giving some rumors also in outside. Then he will drag the game up to the last ball of the match now. But that is a rumor only. But situation is demanding like that. Think a minute about it. And that moment also, if he is in aggressive, if he lost his wicket now, what will be the next situation? Already almost all 8 wickets are down. Only last wicket, and at the other side, MS Dhoni. How we are expecting that aggressive batting there on that moment? Yeah, then because of that reason only, he won the matches. See, just think a minute about it. In World Cup match, World Cup final, when he won that World Cup, he was a survival at that moment. He was a savior. If he lost MS Dhoni wicket a bit earlier, what will the situation? He brought the game up to like what there last ball in the sense last run of the match. Yeah, then there we can identify some qualities that we have to get it. Right, sir? It's okay, fine. Come for it, no? Now, thread the life cycle. Coming for our point here, life cycle. See, biographies, if we take now, what we can see there in Mahatma Gandhi biography, for example, the writer has given that all the states, right from born state to dead state. Yes, sir. Am I right or not? The writer who has written that Mahatma Gandhi biography, he maintained, that means he maintained all the important phases of Mahatma Gandhi, right from born state to dead state. The collective information of a particular person, right from his born state to dead state, is nothing but what their life cycle. In other words, born state, dead state, again born state, dead state, again born state, dead state is also be called as what their life cycle. Cycle. Get my point on it? Similarly, in Java applications, in Java, we are going to use threads. Number of threads we are going to use. So many threads we are going to use. So many threads we are going to use inside the Java. But what exactly the collective information of a thread, right from its born state to dead state? What exactly the details of a particular thread, right from its born state to dead state? Then that is called as what? Life cycle of a thread. Got my point or not? Now the point here, what I'm telling there, the collective information of a thread. See, the sentence framing is my own framing here, but don't think it is mandatory. In our own way also we can understand it. Finally, the important phases of a thread, right from its born state to dead state. That only the main point here. Okay, the collective information of a thread, right from its born state, starting state, born state to the dead state. is called thread life cycle. Right, sir. Thread life cycle. In Java applications, observe careful. In Java applications, every thread will have the following life cycle stages. What are the various life cycle stages are available? First one is new or born stage. First one is what the new or born stage. And the second one is what their runnable stage. Second one is what their runnable stage. Third one is what running stage. Fourth one is what their blocked stage. But for this blocked state, so many names are available. In the diagram, I will show all these names. Last one is what? After this, dead state, dead or destroy stage. Dead or destroy stage. These are overall states are available. Okay. Then we are going to understand how all the states are going to be available. New or born state, runnable state, running state, blocked state, dead or destroyed state. These two states are very, very important. Running state and blocked state. These two states are very, very important. Our threads are going to be available more and more in these two states only. New or born state is one time. Runnable state maybe one time or maybe some other times. But running state is continuous. Blocking state is also blocked state is also like what they're continuous. Continuously we are going to stop the thread. Continuously we are going to execute the threads. So this kind of things are going to be happen. Okay. Right, sir. Then through a diagram, I'll explain this total particle. Okay. Right, sir. Then tomorrow I'll explain about this total diagram here so that we are able to get some content here. Anyway, on Sunday, this Sunday we are going to complete this total topic, multi-threading. Then Monday onwards we'll plan for what there IO streams, input and output streams topic. I'm going to start on Monday onwards. Okay, we'll plan for it. So that's it. Take some few minutes break and come back now. I'll start advanced Java class. Yeah, guys, advanced Java also I'm going to take in now. Workshop link. Now try to use this if you want to attend in workshop link. Right. Yeah, thank you.